Hello, my name is Wilson, and today I would like to make a presentations about the factor theorem and the remainder theorem. In these presentations, we'll be discussing about the definition of both of the theorem, the proof of the theorem, and the example of a problem based on this topic and how to solve them. Now let's get started. First, we have the definitions of the remainder theorem. The remainder theorem begins with a polynomial, say px, where px is a polynomial p with x as the variable. Then, as the per theorem, we divided the polynomial px with by a linear factor x minus a, where a is just simply a random number. From here, we go through a long polynomial division, which will give us a result of a polynomial qx and a polynomial remainder rx. Remember that the variable q stands for the quotient polynomial. These whole definitions can be expressed as as the as the equations below. Px divided by x minus a equals to qx plus rx. Second, we have the definitions of the factor theorem. The factor theorem is commonly used to factorize and find the polynomial equation root. You can say that the factor theorem is the reverse form of the remainder theorem. The problem of the factor theorem are solved based on the applications on synthetic divisions, and then to check that whether the problem ha ha has the remainder of 0. So in simplified version, when px is equals to 0, then the factor of the polynomial will be y minus x. Or if we can consider it in another way, when the factor of the polynomial is y minus x, then px is equal to 0. Here are the proof of the theorem. The theorem functions on an actual case that a polynomial is comprehensively dividable at least one time by its factor in order to get a smaller polynomial and a remainder of 0. You can say that this proof can be is one of the simplest way to determine whether the value a is actually the root of the polynomial px. We'll be using these equations to find out the proof. Now, from the previous slides, we all know that divided equals divisor times quotient plus remainder. And we remember that we divided the px with by x minus a, the remainder will be constant. So if the r is simply the constant r, we'll obtain these following solutions. Px equals x minus a times qx plus r. And then we will replace all the x with a and observe what will happen when when x is replaced with a. Basically, since in these equations that a minus a is equals to 0, so basically this means it means that PA is equals to 0 plus R, or we can simply just say that PA is equals to R. Here are the examples of questions using a factor theorem. The questions ask us to factorize y squared minus 5y plus 6 by using the factor theorem. In order to solve these questions, we first need to let the py equals to y squared minus 5y plus 6. Now, if py equals to y minus a times y minus b, the constant term will be ab, and as you can see the equation below, dy equals to y minus a times y minus b equals to y squared minus by minus ay plus ab. On comparing the constants between these two, we get that ab is equal to 6. Then we shall find the factor of the ab, which is 1, 2, and 3. Using this factor, we replace all the y's with this number. And after some calculations, we get the we find out that only 2 and 3 give the result of 0. So we can confirm that y squared minus 5y plus 6 is equals to y minus 2 times y minus 3. And here is the example of the remainder theorem. The questions asks us to divide 3x cubed plus x squared plus 2x plus 5 by x plus 1. Using from the questions, we get we able to find out the divided and the divisor, which is 3x cubed plus x squared plus 2x plus 5 for the divided and x plus 1 for the divisor. From here, we need to use the divisor and multiply it in order to reduce the divided to the point that it the divided is not dividable, and giving the last remainder. So basically, from these equations, we get that the quotient of the solution of the solutions is 3x cubed 3x squared minus 2x plus 4, while the remainder will simply be 1. That's all for today, and thank you for listening, and see you.